Okay, we have this function y equals x plus 3 over x minus 2. That's what we call a rational function. We'll talk about that. So I pose a question. If you're viewing this and haven't seen it before, don't even look at the rest of what's written. Okay, take the question. What are the x-intercepts of this graph? For what values of x is y equal to 0? Those are the points on the x-axis, right? So you should be able to just look at it and see that into the polynomial. Pause the video for a minute and answer the question. Okay, well, clearly if x is -3, you get a 0 in the numerator, and you don't get a 0 in the denominator. Okay, you get 0 over 1, and that's 0. So the 0 is at x equals -3. And what's the y-intercept? Again, pause, figure that out. Maybe take the hint. Y-intercept occurs when x equals 0. If you don't know that by now, ponder why you don't, because it's used a bunch of times. Okay? Well, hopefully pause, the y-intercept will be at 0 and -3/2, because if x equals 0, you get 3 here and -2 here, which is 3/2. What's the domain of this function? The domain is a set of all x values that you can plug into this function. Okay, so think about that. Well, you thought about it. The domain consists of all values of x except 2, because you can't divide by 0. And x minus 2 is 0, if x equals 2, right? So your denominator can't be 0. Denominator 0, the function is not defined, not in the domain. So here's your domain. Now, don't have the answers here, so you ought to think this through. Again, if you're watching, you haven't done this already. X is 2.01, what's y? So, x is 2.01, your denominator here is 2.01 minus 2, which is 0.01. The numerator is 5.01. How many 0.01s does it take to make 5.01? It takes 100 0.01s to make 1, it's going to take over 510. The answer here is y equals 501. Okay. What if x equals 1.999? What's the value of y? And again, plug that in. Do the arithmetic by hand. Rely on your calculator. It doesn't give you any insight to put this into the calculator. 1.999 minus 2 is 0.001. That's 1/1000, and your numerator is going to be 4.999. Well, 1.001 goes into 1,000 times. It'll go into 4,000 times. It'll go to 999 times. You're going to get. And hopefully your arithmetic showed you that and you understood what you did. So it'll stick with you so you'll understand these graphs. Okay, so if x is 102, what's y? Well, you put 102 up here, you get, well, you should do it. You get 105 divided by 100, which is 1.05. X is close to 2, but a little greater than 2. What can we say about y equals x plus 2 over x minus 2? Well, this is a little greater than 2, but it's close to 2, you get something big. If you get closer to 2, that'd be like you have 2.001, you get 5,001. Okay? Closer, this number is to 2, while staying greater than 2, the closer y gets, or the bigger y gets. Every time you add a 0 in here, this gets about 10 times bigger. It's huge. So we can say that the denominator is small, so y is big. See that from here. And the smaller your denominator, the bigger your y. I'm not convinced of that. Use 2.001. See what happens. 2.00001. Very straightforward. Okay, what happens as x gets closer and closer to 2? It stays less than 2. get back to the lesson here, and I said this is 49.99 because I'm doing the number, it's negative 49.99 because the denominator would be 1.999 minus 2, giving me a negative 0.001. It's at 0.001. Okay. To emphasize how big it gets, I just equated it at that negative side, but it's negative. Now, if you take the lesson here, what's it tell you? It tells you, well, if x is close to 2, then x minus 2 is going to be a small number. If it's less than 2, x is less than 2, it's going to be a small negative number, and your numerator is going to be pretty close to 5. So you're going to get a small negative number divided into 5. So no limit to how small that number can be, no limit to how close you get to. There's no limit to how big some y values get. So again, the denominator is small and gets smaller. So the magnitude of y, the absolute value of y gets bigger, but y stays negative because that denominator is going to be negative as long as x is less than 2. X is negative 9,998. Well, negative 9,998 minus 2 is negative 10,000. And you divide, negative 9,998 plus 3 is negative 9,995. So you're going to get what make you say? It's over 10,000. And you get y is 0.9995. And well, if you did the calculation, you understand that if x is a big number, whether it's positive or negative, the numerator is going to be pretty close to x, and the denominator is going to be pretty close to x. 9,998 plus 3, 9,998 minus 2. Oh, different one, they're both about the same size, and they both be negative, so you're going to get something here. Well, this number is close to 1, and this number is close to 1. Now, this number is closer to 1 because this is a bigger number, but this number is pretty close to 1. What's this tell us? This tells us that if x is really big, what can we say about y? Y is going to be close to 1. Okay, now we can construct the graph. Okay, so you ought to do this. Take all the information we have here and see what you can do on the graph. Okay, well, hopefully you've done that. First thing you do, you got a 0 at x equals negative 3. That means you got a point. Negative 3, 0. The y-intercept is a 0, negative 3 halves. Well, I'm going to put 0, negative 3 halves. Well, there's your y-intercept. You got those 2 points. You know that. Now, it might not be obvious what to do about this other information, but if you think about it, the points where x is equal to, or nearly equal to 2 are really important. So it would make sense to draw here to where x is 2 and sketch all the points where x equals 2. That's a lot of points. You make an infinite number of dots, no, you can't. But here's a point where x equals 2. That's going to be the point of 2. Another point where x equals 2. Well, any point above below this is going to have x coordinate 2. And down here, down to this point, and it becomes clear now that these are all the points where x equals 2. Okay. On this one. Okay. Then what do we have? For all big x values, y is going to be close to 1. Well, That means we might want to draw all the points where y equals 1. So if this is the point 0 and 1, you just draw a horizontal line through this point. Y is equal to 1 on every one of those points. So these are points where y equals 1. Now we can take all this information, put it together, and get a pretty good idea what this graph looks like. Okay, the graph has to go through these 2 points. When x goes this way, and this is a big negative number, it's got to be close to 1. When x is a big positive number, of course, that also be close to 1. It's got to go through these 2 points. It's got to get close to the line x equals 1. All right, so there's a graph. Now what happens as we get close to x equals 2? We're getting close to x equals 2 from numbers that are less than 2. The closer we get, the bigger our negative number is going to get. Okay? So we're going to get bigger and bigger and bigger negative numbers. This thing just goes on. It gets closer and closer to this line here, where x equals 2. And this is what we call a vertical asymptote. If I have a little more room, and smart enough to leave myself a little more room, I'd have written out the full description of vertical asymptote to the line x equals 2. Up here, x as x gets big, we get close to this line. As x approaches 2, we get close to this line. Now, do we do that this one? We get as close to both lines, but we can't for 2 reasons. One is, if we do this, we go through 0 at some x coordinate, but clearly the only x coordinate that makes this y value 0 is when x equals -3. Okay. So here, we're going to have a line starts out close to x equals 1, and then get close to y equals, start close to the line y equals 1. So we're going to get close to the vertical asymptote x equals 2. And this is totally consistent. We've seen that when x is close to 2, but a little greater than 2, then y is big. And the closer it is, the bigger y, and that satisfies the whole thing. So that's an introduction to rational functions. Now, there's much more to it. Then a rational function is a polynomial here over a polynomial here. The way to figure out the graph of a rational function is to factor the numerator and the denominator. So you might have like an x plus 3 times an x minus 4 divided by x plus 6 times an x minus 7 times an x squared plus 8. A bunch of different factors, and you'll see that. So this is a simple rational function. Just a simple linear function, a simple linear function. They get much bigger, and of course, you're going to see that. Okay, so we pose the problem. Which function inverse to y equals f of x equals x plus 3 over x minus 2? Now, class knew switch the values of x and y. Then solve that equation for y. So we switch x and y, solve for y. Easy to switch x and y. You got y equals x plus 3 over x minus 2. We switch, we get x equals y plus 3 over y minus 2. Now we solve for y. Basic principle that I have trouble getting people to believe. If you have a denominator in an equation, multiply both sides by that denominator. Also note that what you multiply by can't be equal to 0. So together. And we know why can't it equal to, because we did, we can multiply by 0, right? I have to exclude y equals 2. That gives us this, because first I multiply numerator and denominator here, and multiply numerator and denominator here, and I can put one denominator to multiply. You see that this equals 1. So we can say that one minus 2 times x equals 5 plus 3. Then we multiply through, we get xy minus 2x equals 5 plus 3. And we're trying to solve for y, so we get everything over on the left-hand side. Every y term on the left-hand side, we get xy minus y. We add the 2x to both sides, and we get 3 plus 2x. So this gets a little tricky, you know, there's little steps here that you gotta be careful about. When we have this, how are we going to solve for y? We got an xy, we got a minus y. What are we going to do about that? Well, factor out the y. This tells you that y times x minus 1 equals 2x plus 3. So y equals 2x plus 3 over x minus 1. So that's inverse of that. If I did that right, is equal to 2x plus 3 over x minus 1. Now we check. Inverse function is a function that undoes the other one. Okay? So if f undoes f inverse, that means if you start with x, you've got to end with x. Something that's worth pondering. So f of f inverse of x is f inverse of x plus 3 over f inverse of x minus 2. Okay, so now what that inverse of x is 2x plus 3 over x minus 1 plus 3 divided by f inverse of x and 2x plus 3 over x minus 1 minus 2. So I'm going to have to skip a couple of steps. We've got time, but other thing that we want to do. And presumably, if you've done the preceding sections, you know how to do this, but we'll have to work on this. Okay. numerator overcome denominator, we get this. And then the denominator. Again, put these over common denominator, we multiply numerator and denominator in this term by the x minus 1. 3 times x minus 1 over x minus 1. And so forth, and hopefully we understand that. So we're getting somewhere. Well, we distribute this and put it all together, we get 5x plus 2 over x minus 1 divided by 2x plus 3 minus 2x minus 2 is minus 1. And it looks like maybe I made a mistake. This isn't going to work out. Okay. Minus 2. You can get 2x here. Substitute off. I should have had a 2 times by 2x plus 3 here. And looks like my design. And then 2 here, this ends up being a 4x plus 6. Now that ends up 7x. That's 3 something off. Okay. We're not going to get it. So at this point, I think that works. Of course, I just pretended to make mistakes so I could illustrate that you need to check it, see if it really works. And if you believe I just pretended to make that mistake, you look too far. Okay, I really made a mistake. I'm not seeing it right now. But you do the algebra here carefully and be cautious. It's algebra trivial, apparently. And looking at it, I'm still not seeing it. No, not seeing it. Okay. Well, anyhow, that's a process. When you do it right.